Okay, so my name is Paco de la Cruz. I work for Mexia as a senior development consultant. And tonight we're going to talk about durable functions and how to build serverless and stateful orchestrations on Azure. So how many of you have worked with Azure functions? A couple of you. And what about durable functions? Okay, nice. Introduction? Yes. Nice. Okay, so hopefully you learned something, or hopefully you can share something with us tonight. Okay. So these are my contact details, so you can flick me an email on my Mexia email, or you can follow me on Twitter or connect via LinkedIn. This presentation is on my SlideShare, so if you go to slideshare.net/Paco de la C, then you will find my presentation. And I've been recognized as MVP quite recently, a couple of weeks ago, actually 1 week ago. So the agenda for tonight, first we're going to have a quick overview of serverless and functions, and then we're going to go deep into durable functions, why we need durable functions, what kind of patterns we can implement, the different components we can use to build these solutions, and then also a bit of a comparison between logic apps and durable functions. How many of you have used logic apps? A couple of you. So logic apps is also a serverless platform, and it's also to build workflows. So it's also, you can build also stateful workflows on Azure with logic apps. So I'm going to do a very quick comparison between the two, and then hopefully we have time to run 2 demos, very similar but different scenarios, or different exploring different functionalities of the tool, and some Q&A. Okay, so serverless. So what do we mean with serverless? So before the cloud, everything, if we wanted to deploy an app, we would need to create our own or install our own server on premises and then deploy all different components and dependencies. And then the cloud came along, and now we can use infrastructure as a service. We can create VMs and deploy our applications over there. But still very cumbersome. We still need to have to patch those VMs and everything. Then PaaS came along. With PaaS, now we don't need to worry about VMs. We just deploy our apps, and then scaling is very easy. We don't need to worry about high availability. It's all managed for us. Very convenient. And the last wave of evolution in these application platforms is serverless. So serverless is you don't worry about servers. You just worry about your code. Does it make sense? Yep. So what serverless is and what their benefits are. So serverless is, it doesn't mean there are no servers. Of course, there are servers behind the scenes, but we don't care about those servers. Those servers are fully abstracted for us. And we just care about our code, what type of solution we want to build. We just focus on innovation. And then scaling is all event-driven. So before, for example, we deploy a solution to an app service, we need to think about memory consumption, CPU consumption, and then, okay, add a new instance of a VM, a PaaS VM. With serverless, we just don't care. We just care, okay, if there are new events, just spin up new instances regardless of the VMs. We don't care about VMs. And also, we only pay for what you use. So if you have peaks and then you have a lot of idle time, then serverless might be a good answer for you as well. Okay, so Azure Functions in a nutshell. So Azure Functions is little pieces of code that you can deploy on Azure. And you can write them in C#, F#, JavaScript, Java, and Python, depending on the runtime you're using. There's runtime v1 and v2. And then there are different triggers. So these triggers can initiate or instantiate a new instance of your function. So there are many different bindings. Service bus queues, for example, if you receive a message in a service bus queue or on a topic, event hubs, webhooks, HTTP requests, even Cosmos DB. If a document is created on Cosmos DB, you can create a new instance of a function. Also blob storage, we're going to see in the demo. So these triggers will create a new instance of your function. The function will do some processing and then put the output in another service or protocol. So again, we can send these outputs to event hubs, to service bus, to Cosmos DB, and there are also third-party bindings. For example, if you want to send the output to an SMS message, you can use the Twilio binding. Or if you can send an email, you can use the SendGrid binding. So I'm going to use the send grid binding tonight. Okay, so durable functions are very, very handy, but there are some limitations. So for example, one of the key limitations of functions is that they can only run for 5 minutes, or well, 10 minutes. By default it's 5 minutes, but 10 minutes. What if you have a background process that is meant to run for longer than 10 minutes, right? Or maybe you have different steps that you need to correlate. So what if you have a sequence of functions that you need to correlate? Probably you have 3 functions, then okay, you can pass one message, let's say function 1, 2, and 3. You can pass a message through a queue, or you can even call an HTTP endpoint to call the second function. Probably this is okay. But what if you want to know how the workflow is working? What if you need to implement error handling? So what if function 3 fails and you need to compensate what function 1 and function 2 did, right? So all these complex scenarios would be very hard to manage just by using functions. Okay, and then another scenario would be fanning out and fanning in. So imagine you need to execute some processes in parallel, some functions in parallel. And then after that, you need to fan in and get the output from those 3 functions and continue your processing. That would be very cumbersome if you only had the normal functions, right? What if you have a very long-running HTTP API that you want your client to call and check the status, if it's still running, if it has finished? What if you have this process that runs, let's say, for 1 hour, and you cannot have an HTTP request for 1 hour, right? So what if you want your client to be calling and checking if the status is finished or not? Very similar if you want to have a flexible monitor that is checking how the function is executing. And also, what if you wanted to implement a human interaction process? So what if you imagine a human approval process, right? So you send, do you approve this PO? Do you approve this invoice, right? And then you're waiting for that person to approve or reject that PO, for example. And you also want to have a timer. So let's wait for, let's say, 1 day. If for 1 day we don't receive anything, then we mark the PO as rejected, for example, or we escalate and we send it to another one. And what if you wanted to have, let's say you spin up, so all these are within functions, but what if you call different APIs that are not in your control? These APIs might raise a webhook at the end of the execution. So what if you let's say you call 3 APIs completely out of your scope? You cannot change how they behave, but at the end of their execution, they raise a webhook. So you can correlate those webhooks into one single instance of your process and then continue from there, right? So imagine you have your CI/CD pipeline. So you trigger your CI/CD pipeline, and then you want to see how the build went and get the outputs from the build and get the outputs from the release pipeline, right? So you can correlate all those events. So doing that with functions is very, very hard. But now, this is the challenges we can implement with durable functions. So all these challenges that we discussed now are patterns in durable functions. So the first pattern is function chaining. So you can call different functions, and then let's say the output function 1, we can pass as an input for function 2. And then output for function 2, and input for function 3. We can do this very easily with durable functions. Also fanning out and fanning in, very, very easy. We can call different functions in parallel, and then get the outputs from all those functions, and then continue running with the outputs of all those functions. Very, very easy. Again, functions allows you to have this get status, check how the API is running. If you have a very long run, imagine you have an orchestration with so many steps, and you want your client to check how this long running process is doing, you can check your status very, very easily. Very similarly, you can do this monitor. You can create this flexible monitoring of your API, checking how this is one function monitoring another one. Implementing human interaction processes, also very, very simple. We're going to do this in the demo. So you can send external calls to let's say you send an email, and then you want to wait until that email there is an action on that email, and then you can continue. You can implement all these durable functions. We are going to see exactly this pattern tonight, and then you can correlate different events coming from different webhooks into one call. All this, if you go to the documentation, you will see pattern 1, 2, 3, 4, 5. I don't know why, but they haven't created the external events correlation pattern yet on the documentation, but of course you can do it. Okay, so with all that said, so what's Durable Function? So Durable Function is an extension built on top of Azure Functions. And it's based on a framework called Durable Task. So they use the Durable Task framework to implement this framework, this extension. And they are using Azure Storage and Azure Storage tables and Azure Storage queues to do all the state management for you. And all this state management is fully abstracted for you, so you don't need to worry about that. And it allows you to implement these workflows, as we discussed, these patterns with code. So you can use C#, F#, or Node.js is currently in preview. Okay, to build these solutions, there are different components. So we have the orchestrator, right? So this orchestrator is the process manager, is the function that is in charge of orchestrating or saying, first execute this function, then this one, do this. And you can use all your constructs you are familiar with, conditionals, loops, switch cases, error handling, all that you can do in your durable function, orchestrator function, sorry. You would call what is called activity functions. So those little steps are called activity functions, so you would call those from the orchestrator. So error handling, compensation, as I mentioned. Checkpointing, every time we call an activity function, we persist the state. So when the orchestrator is calling the activity function, it dehydrates. Well, this is a term they use, which means the whole state is persisted into a table, and then it sends a message via storage queue to the activity function, and this is persisted into a database, into a table, sorry. Once this function finishes, this function sends a message back, right? So let's say you have a very long-running process. Let's say this is sending an email and waiting for a response for 24 hours or 48 hours. This orchestrator is persisted in a table, so you don't need to pay. You don't need to pay for what this orchestrator is doing. So it's very cost-effective, because when this is waiting for an activity, when the orchestrator is waiting for an activity, you're not paying for that. Yeah, and then when we receive the message, the orchestrator rehydrates. So all the state is reconstructed. We're going to see in the demo. And then the orchestrator continues execution. And then the activity functions. So the idea is that you follow the single responsibility principle. So this function, the orchestrator, is in charge of managing the process, and then each activity step will run just very specific activities or nano services. These activity functions expect inputs from the orchestrator and will return outputs to the orchestrator. And then we have the client. So the client is the one that can start an orchestrator, can get the status of an orchestrator, can send events, and can also terminate. Right? So the client can terminate. Let's say you have some conditions, and then you say, okay, I don't want to continue with this orchestration anymore. You can terminate or kill that process. And this is just a sample of the code you would be implementing. So imagine you want to chain function 1, 2, and 3. Yeah? So we have a context, right? So we have the orchestration trigger, right? And then we have this context. So this context allows us to call activities in an asynchronous manner. So we call this function 1, and we await, right? So this await is when the orchestrator dehydrates. And so we specify what type of object we are expecting, and we pass the input, right, to that function. So for example, we get x as output of f1, and then we pass x as input for f2. These x and y have to be serializable objects, right? So because these messages are serialized into an object that is put into a message that is put into storage queue. And then, as I mentioned, so you can implement error handling, same way you would do it in C# or F# or Node.js, right? So the construct you're familiar with. So if any of these functions fails, activity functions, then you can do some compensation in the catch block. So this is the function chaining when you want to call different functions one after the other. And then this is fanning out and fanning in. So here we also have the orchestration trigger. And for example, here we have an array of objects, and for this array, we are looping, and then we are calling another function. And we call these functions asynchronously. So let's say this array has 10 objects. We will call 10 times this function too. And then the way to fan in is to use the when all, right? So this, if you are familiar with parallel processing on C#, then you will be very familiar with this when all. And we also have the option of use when any. So so we can use when any. So if the first one finishes, then we can continue. We will need just to cancel the other functions if we just don't want them to run. Okay. So the dehydration happens. Yeah, it's a good question. So let me think about it. So we call activity async, and then so the rehydration happens with every output. I think now your question is, I think based on the construct, it will execute this. Actually, yes. So it will call this one and it continue, right? Because of this construct, it will continue, and then rehydration will happen with every response, and then when all. Yep. Mm-hmm. Yep.
Is it fast enough to know not to hydrate and rehydrate and stay around for a little bit of time, or does it do it for every single request?
Yeah, that's a very good question. So there is I don't remember the name of the option, but you can say, okay, keep this in memory. You can keep this in memory, but you need to know that you will be charged for that, right? But if your process is better not to dehydrate, then you can do that. Yep. Very good question.
Are these literally function calls, or are they actually calling to the HTTP stack?
No, so when we call the activity function, it's all via messages on a queue. So we put messages every time we call this activity. We put a message into a queue, right? And this queue will trigger this activity function. So it's important to know, this is a workflow for long-running processes. So don't expect this to be very high throughput, right? So this is not for a super high throughput scenarios. You can tune it, like keep the orchestrator in memory, but this is not for very high throughput scenarios. So you're just putting a message into the queue, and then this activity function is polling from that queue, right? So there is a bit of a delay here. But for workflows where you don't need to have a very high throughput, it's okay. So there are some scenarios where you might not want to have this, right?
Well, the throughput it can get quite wide.
Mm-hmm.
The end-to-end speed is a bit laggy because there's all of the rehydrating and waiting and
yes.
off all the functions.
Yeah.
But you can get thousands of functions wide and get great bandwidth.
Yes, because you have parallel processing. Yes. Very good point. Yeah.
And with the length of your program or your orchestration, because it does replay, does that take longer then to replay the actual dehydration as your program becomes more complicated?
Yeah, that's a very good question. So if your orchestration is very long, then it has to go through all the code, but it won't replay the activity functions. So it will check this activity has been executed. I have the output, so it's using event sourcing. Yeah, so it's reconstructing the whole state based on event sourcing. It gets the output from the previous execution. It will reconstruct the whole. But yeah, if you have a very long process, it will take very long. So for example, this is a very good point. If you had an infinite loop, right, then it will become, so imagine this iteration is like 10,000. Every time it rehydrates, then it's going through the loop, right? So, yeah.
Last question. JavaScript.
Yep.
Is that now available as an orchestrator? Because beforehand it was only available as a
Activity, yes, yeah. It is available in preview. So when they release the 1.4, it's available in preview. Yep. Any other? Yep.
You mentioned before if you were doing on the task when any,
Mm-hmm.
would you have to cycle through and cancel each individually, or
Yes, yeah. You can use the same cancellation token. So the question was, if we use when any, we need to cancel all those open activities, right? So we can use the same cancellation token, and that's it, yeah. Any other question? No? Very good questions, thanks. Okay, and this is the client. So the client, so we use, this client is triggered by an HTTP request, right? And we're using the orchestration client, and then what we do is we get the input from the request, right? And then we start new async, or we pass the name of the orchestrator, and when we pass the input, and then we can create a check status as a response to the client, right? We will see this in the demo.
The client will always have to be an HTTP triggered client?
No, we will see in the demo a different one, yeah.
Do you get type safety when you call stuff? I know some of your code's got like dynamic and object and stuff.
Mm-hmm.
You create these little functions, it's all in C#, but then you lose your...
Yeah. So this is a limitation of functions. It's all late binding. So if you see here, my orchestrator is just a string, right?
Yeah.
So this is late binding. It resolves at execution time. Yeah.
But that's for the function names. For
Yeah.
the return types, you get.
Oh yes. For the inputs and output params, yeah, you get type safety.
Yeah, with the generic thing there. But also for the parameters of the activity functions, you also don't get type safety, right? I guess not.
So yeah. So this
Yeah, like event data?
Oh, it's not for that, but in the other example, it's
yes.
an int.
You can pass an actual class. You can define an actual class. This is just an object, but you can define an actual class as your input param, right? And then an actual class as your output param. That's okay. Yeah, and then you get type safety. Yeah, and IntelliSense and all that. Yeah, you can do that. Mm-hmm.
Do they help functions for like item component operations, such as getting the current time and stuff like that?
Yeah, very good questions. So, for example, you can. So there is. I have this slide, but I didn't want to put it. I can show it now. Let me finish this, and then I can show that slide. Any other questions before we continue? So this is the client, and this client again can start an orchestrator, can terminate, can get the status, and all that, can send external events as well.
You mentioned retry policies later. Or?
I don't have much content, but we can discuss that. Yeah. So I'm gonna bring that slide. I didn't know how deep we wanted to go, but very good questions. I appreciate that. So, for example, there are some limitations. I don't know why. It's trying to resolve the monitors and all that, but so these are some limitations on the orchestrator. So the code has to be deterministic. So you cannot create any random numbers within the orchestrator because it has to be replayable, right? So what you can do is generate those numbers in an activity function. But you can get the current date time. You can get it from the context. So the first time it runs, the context can create the current date time, and then next replay, it will get it from the previous state. Yes. So this is for the first question you had. And then it has also to be non-blocking, so we cannot have any I/O in the orchestrator. Well, you could, but then you might lose. Next time you read, then you are not expecting to get any changes. And then, for example, thread.sleep, you cannot use in the orchestrator. You can use in the activity functions. You should never initiate async operations which are not called within the context. And as I mentioned, you should avoid infinite loops because the history table will get massive, and then your performance will degrade. But there are workarounds for this. So, for example, again, you can call some of these. You can call from activity functions. The async, you can use the context, and if you want to have infinite loops, you can use start as new. So you can start a new iteration of the orchestrator, and then you pass the output as input, and it will delete all the history. So next time it executes, it will start as new, no history. And then you can have sub-orchestrators for that as well. And regarding retries, so let's cover that now. So retries, you can have, when you call activity functions, you can specify a retry policy, how many times you want to retry. If let's say you don't have any error handling your activity function. If it fails, it will marshal up the exception to the orchestrator, and then you can have retries. So you can say retry for 3 times, and you can also have some advanced rules like exponential backoff and all that.
So with a timeout for an activity, is that just left up to the infrastructure, like the Azure function timeout, or is that something also you can say only allow this activity to execute for a minute, and if not, cancel it?
We will see that in the demo for the timeouts. You create a timer within the context. You create a timer, and what it does is create a message that will return back at that time, and then you will see what to do with that message, right? We will see that in the demo. But very good question. Thanks for that. Did I answer your retry question?
Oh, I knew the answer.
Okay, yeah. You have used it already. Yeah.
One call it Cosmos DB.
Yeah, for transient errors, for example.
Cosmos DB on the rise.
Yeah, I didn't want to go that deep because so many concepts. But yeah, very good question. Thanks for that.
Can I ask one more question?
Yes,
So
sure.
like with these functions, and like for instance, like when we have like stepwise functions like 1, 2, and 3, is there ways in which you can restart it from certain points? Like if, for instance, I have 3 steps and I wanted to restart from second step or third step, continue from there. Basically, the state of the orchestrator, it being persisted, and you being able to access it again later on.
Not out of the box. You can have these retries, for example, right? You have all of these advanced retry policies. So you can say retry for 20 times, and then if it fails, then you will need to start the whole orchestration again. Yep.
So on that note, I'm assuming we've got one Azure function with the code in it. And as the code goes from V1 to V2 to V3, there's only one copy of the code in the Azure function, so there's only one copy of the orchestration. Similar, sort of related to this question here. How does it know which version of the Azure function to replay? So as you make changes to your running orchestration,
Yeah.
how does it know how's that binding? Is there a binding there, or?
Yeah. That's the most painful question I have. That's the most painful limitation of durable functions at the moment. Yeah.
Virtually creating a brand new function for the next version.
So there is in the docs. I'm sharing the link to the docs. So they have some mitigations for the versioning, because if you deploy a new version of your orchestrator or the whole durable function solutions, it will break. If you're changing the signature of your activity functions, or if you're changing the sequence of your orchestrator, it will break all running or all in-flight instances. So there are some strategies to mitigate that, right? For example, you can have blue-green deployment, so you have one version and then you deploy side by side, for example, right? And then you let all your running instances finish, and then based on the client, now redirect to the new version, something like that. There are different strategies, but yeah, I would say that's the most painful limitation of durable functions at the moment. But yeah, this is, if you want to have any kind of state management implementation, this is one of the hardest bits, right, to implement. Logic Apps does a very good job on that. You can have different versions running at the same time. Durable functions at the moment don't support that. Yeah, very, very good questions and about advanced questions. Thanks for that. Okay, let's continue. Otherwise, okay. So yeah, so let's go through this. This was also hidden, but so yeah, your question. Every time we call an activity function, we're using queues, and then we persist the state of the orchestration in a table storage. Then every time the orchestration, we receive a message, orchestration is replayed, and activity functions are not replayed, and they're using event sourcing pattern, right? So these two slides were hidden, but yeah, all good now. So let's continue. Okay. And bear in mind that, So Durable Functions just went GA a couple of weeks ago. So this is the very first version like you can use in production. So it's very, very early stages. I think within the time they will start releasing new features. Yeah. Okay, so Durable Functions versus Logic Apps. So in Mexia, we heavily use these two technologies, among others, on Azure. And yeah, we've been working with Logic Apps quite heavily as well. So there is a healthy overlap in these two technologies. So both are serverless and both allow you to implement stateful orchestrations on Azure. But some differences. So in Durable Functions, you can use your coding. Like if you prefer coding, then it's a great option. You can use F#, C#, F#, and JavaScript, Node.js. And in Logic Apps, it's all visual designers. So you visually can create these workflows. So if you don't want to code, or if you have people that prefer visual designers, then Logic Apps is also a very good option. The main differentiator one of the main advantages of Logic Apps is the extensive list of connectors. So at the moment they have more than 200 connectors to connect to a lot of protocols and third-party apps, SaaS apps, and all that. Very rich list of connectors. And with functions, you have roughly 20 different bindings available, supported, depending on the version of the runtime you're using. But still very, very, very handy list of connectors. Durable Functions, the runtime of functions can run pretty much everywhere on serverless on the cloud, but also you can deploy on containers. You can deploy on your server with the runtime. You can run them on Azure Stack. So you have many options. You can deploy them on your app service environment, and then on Azure you can have dedicated connectivity to your on-prem. All that options you have with Durable Functions or functions, and Logic Apps can only run on Azure. Another big difference, so Logic Apps have very, very rich capabilities and tools for monitoring and retrying and resubmission and all that, while Durable Functions is just basic APIs to manage at the moment. So I think they're working on this, and also some app insights logging. And yeah, as I mentioned, Durable Functions can run serverless, dedicated environment or even isolated on app service environment. And Logic Apps can only run serverless at the moment, but they're working on an integration service environment, which should be released later this year, probably at the end of this year, and which will allow you to run Logic Apps on dedicated instances. Yep.
So you can't run Logic Apps on an app service plan?
No, you can't. And what they will do is, this is integration service environment. It won't be an app service environment. So you will need to pay for both. If you have an app service environment already, if you want to use Logic Apps, then you will need to pay for an integration service environment as a separate product.
Yeah. So Logic Apps that you can create an Azure function as an action?
Yeah. So in Logic Apps, in the designer, you can say, okay, I want to call a function, and then you can say create a new function. So you would create the CSX version of the function, and you can do that. But at the end, you can call any functions. If you have already published function, you can call it from your Logic App, right? So you could implement everything we discussed. All these patterns can be implemented on Logic Apps. I have a blog post where I compare almost every single feature of both platforms, and you can see the differences between Durable Functions and Logic Apps. There are some scenarios where Logic Apps are really good, and there are some scenarios where Durable Functions are really, really good.
Do you have an example of those scenarios?
Yeah, for example, if you want to integrate, let's say you want to integrate with Salesforce, and then you want to integrate with, if you want to make use of the connector, Salesforce, Twilio, or probably Twilio not the best example, but you want to integrate, let's say, with 5 different systems, and the connectors are available on Logic Apps, then probably you want to use Logic Apps. If you don't need any connectivity, and you don't like visual designers, because this visual designer has some limitations. So if we go back in time, the very first version of Logic Apps was built on top of the resource manager engine. So all this parallel processing that the resource manager has, when you're deploying resources on Azure, you can deploy, I don't know if you're familiar with the depends on, right? So this depends on is the same you have in Logic Apps. So it was built on top of that. So many of the functions you're familiar with when you're building ARM templates are the first functions that were available on Logic Apps. So many people don't like this. When you are nesting all these functions within the Logic App, can become very cumbersome. And it evaluates from the inner to the outer. So it's a big limitation.
Is there a time when you've actually used the WDL over the Visual Designer, or have you always used the Visual Designer when you go into Logic Apps? At what stage do you move into the WDL?
Yeah, so the WDL is a JSON representation of the, So they at the beginning, the designer was not super rich. So you had to switch to the code view and do some tweaks. But over time, now the designer is getting very powerful, very robust. So every time you need to rely less on the JSON definition and more on the designer.
I think specifically in terms of if you're writing complex expressions, etc. It's easier to do it with WDL than
Yeah.
than the Visual Designer.
It's getting better. It's getting better. For example, now the condition builder, it's getting better. The expression builder is getting better. So it's catching up. Cool. So let's continue. And here are very, very good resources if you want to learn more. So you can follow functions, Azure Functions. There is very, very good durable functions documentation. You can watch the webcast or the broadcast of live webcast of the Azure Functions team. There is the repo. So the durable functions framework, and actually the Azure Functions is all open source, so you can see how it's working, and you can even contribute and make it better. There are some samples, and if you have a Pluralsight account, I would strongly recommend this course. It has everything you need to know to start building your solutions, and all the caveats and all that. Instead of reading the documentation and then thinking, oh, I missed this, everything you need to know is in this course. It's very, very good. Okay. One more question before we start the demo, or we go straight into the demo. Yep.
As far as VR and redundancy is concerned for production systems, Logic Apps has a SLA behind it, I'm assuming. So Microsoft look after all of that. We only get the SLAs from the components that we use in durable functions. So we'd have to do our own DR for something like the storage account behind durable functions.
Yeah, it's a good question. Yeah. Yes, I mentioned this is the very first version, right? So it's 1.4, but still very first version. So probably when we reach 2.0, then it will be way richer. Yep. Okay. So let's start. Okay, before we start, I forgot to show you. Let's have some fun. I like this transition. So the first demo. So I built this solution for a real customer. Don't think this is a joke. So this is a cat model agency. It's run by cats, no persons, no people. There is no people in this organization, just cats. And this is my real customer. I do for freelancing. So they have a model, cat model agency, right? And they wanted to. They heard about serverless. They said, "Oh, this is really cool platform, really cool technology. I want to have." And I heard that they told me, I heard that you can build solutions very quickly with this. So can we have an approval process that we can implement serverless? So whenever someone wants to join this very exclusive CAD model agency, so we can say, okay, yeah, you are good enough to join this agency or not. You don't pass the bar. So we build this CAD application approval process. So we're using the human interaction pattern, but this is CAD interaction pattern. So slight customization of the pattern. So this is an overview of the solution. So this is just a subcomponent of the solution we implemented. This is not the whole solution. So there are some other components around, but we're going to focus on this. So there is one picture that is put onto a blob storage container, right? This is the cat that is wanting to join this very exclusive agency called Furry Models. This will start the orchestrator, and then we will send an email for an approval. So the cat will receive an email, and the cat will decide, okay, this is good to join or not so good to join. And then here we are implementing this trigger. So we are creating, this timer. We are creating this timer. At the moment for this demo is 5 minutes. So we start a timer, and then we are implementing this when any. So either we receive the decision from the manager or the approval, the cut approval, or we receive the timeout from the timer, and then when any. Right? So we will see when we have this cancellation token and we cancel any of this. So it's when any, so whatever happens first, and then we need to move that picture into the corresponding blob container, either approved or rejected. Clear? Are you following? Yeah? Very, very simple. Not so simple when we see all this, but still simple process. So now I wanted to show you, okay, all that code is in the orchestrator, right? So that logic is in the orchestrator. But we have an orchestration client. And this orchestration client is triggered by a blob. It doesn't have to be triggered by an HTTP. It's triggered by a blob. So every time we drop a picture on that blob container, we are triggering that function, and that function has an orchestration client. So this is starting a new process, right? And then we send, the next step is to send an approval request via email. So now we're calling an activity function, right? And this activity function is using the send-grid binding. So very easy to create an email and sending it out. So we create an email using send-grid, and then the cat will receive this email on their mailbox. And then they will see the picture of the cat. They will say, okay, accept or reject, right? And then this email has a link that is an HTTP GET. We receive this HTTP GET, and then we can say, okay, this application has been approved or rejected, right? And think that this can be, we can have multiple instances running at the same time. So when you click approve on one specific instance, it has to continue that specific instance, right? So you can have 5 cats sending this request, and you only approve one. So this process has to correlate that response, that external event. Then we continue, and then we move the blob, right? We also have another orchestration client function. I won't show it in the first demo. I will show it in the second demo, but we can check the status, how my process is going, right? Am I being accepted or not? I'm a bit impatient. So some cats are a bit impatient, so they want to know, is it being approved or not? Is it being approved or not, right? Clear? Are you following? Yep. Let's jump into the code. So, okay. Yep, all good. Can you see the code okay? Yep, I can. Better? Yep, so instead of showing you the code, what I'm going to do is I'm going to debug this. So this is something very cool about functions. You can debug your Azure functions locally. You need to have the runtime in your machine. But then I'm going to drop an image in a blob container on Azure, and this will trigger my process running on my machine. That's pretty cool. So I'm going to do this now. I have these sample pictures that we used when we were building the MVP for this customer. So I'm going to put, so if we check here, rejected, there are no files. Approved, there are no files, right? So I'm going to drop picture here. So this should trigger, oh, I forgot to run my Visual Studio. So this should trigger my hopefully I did it before, but hopefully it still triggers my debugging function. So I'm running locally on my Visual Studio, and then I can walk you through the code. So when I dropped that image into the blob container, this should start this process. I'm having the blob binding. Forget about this. We don't care about Java in this presentation. Not using Node.js, so it's all good. Okay, so now, you see, so now it detected the image on the blob container. So now we are debugging locally. That's pretty cool. That's very, very cool. So we have the orchestration client here. I'm using some logs. I'm reading some configuration. And the only thing that I'm using here, I have some kind of pattern in the name. So I'm getting, give me the applicant ID and the application name. So the applicant ID of this email, and then the application name, so we will see later. I prepare, so this is a typed object, right? So I'm using a typed object, and this is approval request metadata, and this is the one that I'm sending. So we have all the type safety and IntelliSense. And then, of course, this is late binding. So we are using calling the orchestrator with late binding, but passing this object, which is typed. So I'm going to let it run, and this will trigger my orchestrator function. So behind the scenes, this is putting a message into a storage queue on Azure, and then my orchestrator is listening to that queue on Azure, and then starting the orchestrator, right? So all the magic is happening behind the scenes. So I'm going to add a breakpoint here, and we will see every time we receive a response from an activity function, this orchestrator will replay. But we have this property very handy. You cannot see the tooltip, but we have context.isReplaying. It's true or false. So for example, I'm just logging if it's not replaying, right? And isReplaying, this property is replaying, only applies until that point. So if you replay again, but then let's say you call activity function 1. Once you finish activity function 1, you pass that, now isReplaying becomes false, right? So after that point, that checkpoint, now it's false. It's the first time that code is being run. So I'm checking some environment variables. And then here, I have this activity function what I'm doing here, I'm going to show you in the second demo. I'm correlating, okay, this applicant ID with this email. This applicant ID, paco02@cats.com.au, is processing this workflow. I'm doing this because I want to have a very friendly way of saying, okay, this workflow has this status, right? Just correlating an entity, a business entity ID with the instance ID. This is a custom correlation. This is not part of Durable Functions, but this is to have a friendly way of correlating your instances. And then this is calling an activity function, right? Then this activity function will return a message, right? And now we are starting from the top, you see? So we are starting from the top, this orchestrator. And now, if I check is replaying, it should tell me true, right? Did you see? So every time we receive a response from the activity function, replays from the top, right? But we can check this property is replaying.
If you had that again, context is replaying, but below where we haven't executed.
Now it's going to be false.
Yeah,
It's smart enough to know. Okay, this is after the checkpoint. So this is replaying is just before the last persisted checkpoint. After that persisted checkpoint, it's going to be false, right? So for example, I'm logging only if it's the first time running. Should jump it, right? Skip it. Now, so we call this one, and now if I check, so I'm going to check that it's replaying. It's false now. Can you see? Yeah. So it's smart enough to check, okay, this is after the last persistence point. So now we have this set custom status, which is quite handy. So when you check the status of an orchestrator, you can check what's the status. This is probably one of the limitations of logic apps. You cannot check if the logic app you can check if the logic app is running, but you don't know what's the current step. With this set custom status, you can know what's happening within your orchestrator. So this is another difference between Durable Functions and logic apps. So I'm setting that custom status, and yeah, so I'm going to send an email. So logging, and now I'm calling another activity function, which is send approval. So I'm going to let it run, and this is going to call another activity function that is using sendRead. So this one is, you can see very few lines of code. I can create an email that I can send, and I'm using a template, and I'm going to show you how this email looks like. I'm going to let it run, and I should be getting an email in some minutes, hopefully. sendRead. Yep. So this is interesting. So it's 7:02, and we receive an email from the future, 7:03. So we get this email. This is just HTML, and this HTML has a picture, and has two buttons, approve or reject. And this is just an HTTP GET. So I'm going to show you here, right? So it's just because I'm running locally, I'm going to make an HTTP GET to my local host, right? And if I click reject, if I click reject, I have a query param, query param saying rejected. But if I click approve, approved, right? So it's just a simple HTTP GET, right? So no, very simple, and the cats love this. So let's say, what do you think? Do you think this cat deserves to join query models or not? Yes? Okay, let's approve this. So this approval is raising, so it's calling now an HTTP GET. I need to continue after this breakpoint. And this should receive, this is going to be a function that has the orchestration client. This is not an activity function. This is an orchestration client that will raise this external event. And saying for this instance ID, they selected approve, right? So this one is even constructing also the HTTP response for the client. So the only thing that this handler is doing is checking the instance ID, the response, and then sending that event to the orchestrator. So I'm going to let this run. And we should be getting a response here as well, hopefully. Hit a breakpoint. But that's weird. Let's continue. Sorry? Oh. So it's the official color for Azure Nights, is it? Try. Still. If you're okay with that lovely blue, not so lovely, but yeah, it's Italian, the Italian blue, right? Azure is blue in Italian. So let's get into the mood of the Italian blue. Yep, okay. So the other one is the same, right? Or not? Yeah. Okay, so let's continue. So let's continue here. So we're replaying. This is all replaying. So now it didn't go into, right? And then we create the cancellation token. No, actually, oh no, we need to wait. Oh, I forgot. I should have let this run because I'm not waiting for the approval yet. I forgot this. But yeah, I got it now, so we should be getting, yep, thanks for your selection here. So I forgot, I should have, so the orchestrator has to wait for that external event. I forgot to run the orchestrator to that point. It was not waiting for that event yet. And then we check the status, approved, set the custom status, and then we have a cancellation token. We cancel it for the timer, right? The timer has a cancellation token. And now we need to move it. So if we go back to so here we are in the requests folder. So if we move this, so this is just a very simple function moving the blob storage. So it was approved, wasn't it? So in some seconds we should see. Now we have the image here in approved, and it should be deleted from the requests. In some seconds, yeah, it's not in the request, it's approved. And then the orchestrator has finished. Cool. Did you follow? Yeah, it's a lot of jumps in the code, but did you follow? So we had different functions having the orchestration client, different functions having the activity functions, right? So I'm going to run it again, but now I'm going to do the reject. So you see this is not fake. So let's put this in the requests. And you can ask me any questions in the meantime. Do you have any questions for the demo? This is the first part of the demo. So I'm debugging. So I'm showing you how to debug the functions locally, and how you can see how the orchestrator and the activity and orchestration client functions are running locally. So this should start again the orchestrator. Some.
So the SLA for this is based on the function that you deploy to, correct?
Yeah. So there are different components, and yes, the SLA. And yeah, so depending on the binding, also there is some response times, right? So there is a long polling for queues and long polling for blob storage and all that. I'm gonna just let it run, and then I'm gonna be receiving another email. So I'm gonna let it run. So now it's waiting for the event. So I should be getting another email. Yep, so now we have another email. So now I'm going to reject this one. So I wanted Michael to be here because next demo is for cats. So probably he could have submitted his cat. So now we rejected this, right? So we should go to the rejected, and we should be, yep. So this is the one rejected, and it should be gone from requests. All good. So imagine implementing this yourself with just even code, forget about serverless, implementing this state management yourself, managing different instances, can become it can be very cumbersome, right? And this is just very few lines of code, all the state management done for, abstracted for you, and just very few lines of code, you can implement all these custom workflows. Any questions before we move to the next demo?
Could you briefly show again, when you click the approve or reject that HTTP request, how it finds the right instance in order to
Yeah, so
process that?
I'm going to show you the email. It won't show the picture because the picture is going through the, well, this one's still showing the picture. But, oh, sorry. So I'm going to, so this one, oops, what's happening? So I'm going to open the email probably. Yeah, so we have, at the moment, I'm running everything locally, right? And then we have the name of the participant, instance ID. So this is the instance of the orchestration. You can be running multiple at the same time. And then you have these all query params. It's just a simple HTTP GET. Yeah.
But then you may have hundreds of orchestrations in flight. When you get through, do you have to find the right orchestration to do something with?
Yes, okay, let's go to that piece of code. So you just pass the instance ID. So let's, so process HTTP GET approval. So what you do is send with the client, you raise event, you pass that instance ID that we're getting as part of that query params, and then we pass what they send as is approved or not.
Okay.
So we can see this in action in the second demo. It's the same scenario, but we can have multiple running at the same time, and we can show this. So it will correlate exactly that instance, right? All this state management is abstracted for you, right? It's pretty cool. So my demo is on this GitHub repo, so you can see all the code there. And also I have 2 blog posts explaining the both scenarios, so how to implement this with SendGrid and Slack, step by step. So I explain exactly how to do it. So you can, it's like a tutorial how to implement this. And so this is talk about a bit about Mexia. So Mexia is continually hiring. So if you are keen on joining Mexia, so we were named Partner of the Year last year, and we were also ranked number 8 best place to work in Australia for small and medium companies, which is quite good. So they invest a lot on people. If you like these technologies, Azure, .NET, serverless, and APIs and all that, yeah. So you're free to join. If you want to talk to me and have any questions about your career opportunities, yeah, just ping me, or you can go to the careers page. And I think we had enough Q&A. So thanks so much. Again, this is my contact details and SlideShare if you want to download the presentation with all the links. It's over there. And that's it. Thanks so much for coming. Thanks so much for inviting.